In section 6.6, we will be solving quadratic equations by factoring. The second and third objectives will be covered in a later course. In these examples, we are using the zero factor property to solve quadratic equations. And that means we have an equation A times B is equal to 0. That's equivalent to A equals 0 or B equals 0. So if we have two factors that are multiplied together that will equal 0, then you can solve by setting each of those factors equal to 0. Now it is important that we remember that you must have a 0 on one side of the equation in order to apply the zero factor property. This is also called the zero product property because you have the product of A times B, where A and B are both factors. In the first example, we have the factor x minus 1 times the factor x plus 4 equals 0. We can use a zero factor property. If we have one factor multiplied by another factor that equals 0, then one of those factors must also equal 0. So we set each factor equal to 0 and solve for x, and we get two solutions since there are two linear factors. And then we check each of those solutions. So let's set x minus 1 equal to 0, and then we can add 1 to both sides and solve. We get x is equal to 1. That's one solution to this equation. And then we set the other factor, x plus 4, equal to 0, and then we can subtract 4 from both sides to get x is equal to negative 4. So we have two solutions to this equation, x is equal to 1 or x is equal to 4. And as always, we should check our work, and we can check our answers by plugging each one of those in to the original equation. So when we check x is equal to 1, plugging it into the original equation, we get 1 minus 1 and 1 plus 4. And 1 minus 1 is 0, and 0 times 5 is 0. So we can say that is a solution. It checks. And we can also check x equals negative 4 by plugging it into each x in the original equation. We get negative 4 minus 1 times the quantity negative 4 plus 4. So that gives us negative 5 times 0, which is also equal to 0. So we know those are the two solutions to this equation. In example B, one factor is x plus 5, the other factor is x plus 9, both multiplied together to equal 0. Using the zero factor property, we set each factor equal to 0. We're going to set x plus 5 equal to 0, and by subtracting 5 from both sides, we get x is equal to negative 5. And we set x plus 9 is equal to 0, and by subtracting 9 from both sides, we get x is equal to negative 9. So our solutions are x equals negative 5 or x is equal to negative 9. And we can check our solutions by plugging those values into the original equation. If x is equal to negative 5, then we get one factor of negative 5 plus 5 times the other factor of negative 5 plus 9 is equal to 0 times 4, which is equal to 0. So that is a solution. And we also want to check x is equal to negative 9 by plugging it back into the original equation. Negative 9 plus 5 times the factor negative 9 plus 9, and that gives us a negative 4 plus 0 times 0, which is equal to 0. So we know that both of those are solutions to that equation. And both of these equations were already in factored form. Just like these examples are already in factored form, so we use a zero factor property and set each factor equal to 0. Since we have a factor times a factor equal to 0, in example D, we have one factor of 5x, the other factor is x minus 15. We're going to set each factor equal to 0. So if we set 5x equal to 0 and x minus 15 is equal to 0, we can divide both sides by 5 here, and we get x equals 0 is one solution to that equation. And by adding 15 to both sides, we get x is equal to 15. So our answers are x equals 0 or x is equal to 15. Both of those are solutions to that equation. And to check, we want to plug both of those values into the original equation. If we set x equals to 0, we get 5 times 0 minus 15, and then we get 0 times negative 15, which is equal to 0. We also check x is equal to 15. we get 5 times 15 times the factor 15 minus 15. And since that's going to be 0, 5 times 15 times 0 does equal 0. In example E, we have one factor 2x minus 5 times the other factor x plus 3 equals 0. Using the zero factor property, we can set each factor equal to 0. Since we have a factor times a factor equals 0, we begin by setting 2x minus 5 is equal to 0, or x plus 3 is equal to 0, and solving each of these, we can add 5 to both sides, and that will give us 2x is equal to 5. And then by dividing both sides by 2, we get x is equal to 5 over 2, or 2.5, or 2.5. And the other factor, we subtract 3 from both sides, and we can solve that for x is equal to negative 3. We're going to check both of these answers, beginning with x equals 5 halves, and we get 2 times 5 halves minus 5 in the first factor times 5 halves plus 3. And 2 times 5 halves is 5, and 5 minus 5 is 0, so that's going to be 0 times anything is going to be 0. So that is a solution. And we also check x is equal to negative 3, so that's going to be 2 times negative 3 minus 5 times negative 3 plus 3, and that's going to give us a negative 6 minus 5, or negative 11, times 0, which is equal to 0. Okay, in these examples, we are solving the quadratic equation. It is not in factored form, so we need to do an additional step before setting each factor equal to 0. In example G, we have x squared minus x minus 30. We want to first put this in factored form, and we want to find those factors of negative 30 that will add up to negative 1, and the factors are negative 6 and a positive 5. So that means our factors are x minus 6 and x plus 5. Now we can use the zero factor property by setting each factor equal to 0. So if we set x minus 6 equal to 0, or the other factor x plus 5 is equal to 0, by solving each one of these, adding 6 to both sides, we get x equals 6. Subtracting 5 from both sides, we get x equals negative 5. So those are the solutions to the quadratic equation. Now, one thing to keep in mind, that a quadratic equation is in the form of x to the second power, so that means you can have two possible solutions. Later on in later courses, you'll see that you can be solving equations that are in the form of x to the third power. That means that you could have a possible 3 solutions. And in every case, you do want to check your work. So if we check x equals 6 by plugging it into the original equation for x, so that's going to give us 6 squared minus 6 minus 30, and that's 36 minus 6, which is 30 minus 30 equals 0. We also want to check x is equal to negative 5 by plugging that back into the original equation. Negative 5 squared minus a negative 5 minus 30. Okay, and negative 5 squared, that's going to be 25. Minus a negative 5 is plus 5. And 25 plus 5 is 30. 30 minus 30 is equal to 0. In example 8, we have x squared minus 9x plus 20 equals 0. We can set this up to use a zero factor property by factoring the trinomial. We look at the factors of positive 20. Let's find the factors of 20 that will add up to negative 9. And those factors would be negative 4 times negative 5 equals a positive 20, and negative 4 plus negative 5 equals a negative 9. So we factor, we find the factors x minus 4 and x minus 5 equal to 0, and now we can set each factor equal to 0 to get x minus 4 equals 0, or x minus 5 is equal to 0. By solving each of these, we find the solutions, x equals 4, or x is equal to 5. Okay. As always, we want to check by plugging those values into the original equation. Let's check x is equal to 4. Into the original equation, we get 4 squared minus 9 times 4 plus 20. 4 squared is 16, minus 36 is a negative 20, plus 20 does equal 0. And then let's check x equals positive 5. Plugging back into the original equation, we get 5 squared minus 9 times 5 plus 20. And 5 squared is 25, minus 45 is negative 20. Negative 20 plus 20 is equal to 0. Let's solve x squared minus 7x equals 0 using the zero factor property, or the zero product property. We can factor this, it's a binomial. We can do that by finding the greatest common factor. The GCF of x squared and 7x is equal to x. So we will be factoring out an x from each of those terms. And when you factor out an x, it's like you're dividing each of those terms by x. And we have x squared divided by x will give us x, and minus 7x divided by x will give us a minus 7. So we have two factors here. We can use a zero product property by setting each of those factors equal to 0. We can set x equal to 0 and x minus 7 equals 0. So our solutions will be x equals 0, or by adding 7 to both sides, we get x is equal to 7. We have these two answers, and we can check. As always, we want to check our work. We check by replacing the x in the original equation with 0, and that'll give us 0 squared minus 7 times 0, which is equal to 0. And then we also want to check the other answer, x equals 7. And that's going to be 7 squared minus 7 times 7 is equal to 0, or 49 minus 49 is equal to 0. Now in example K, we have x squared equals 25. We cannot apply the zero factor property because we don't have a 0 in the original equation. So we've got to do some modifying here. We can subtract 25 from both sides of the equation, and we get x squared minus 25 on the left is equal to 0. Now we can start to think about using the zero factor property because we have a 0 in the equation. We do want to factor the x squared minus 25, and you can factor that if you recognize the model equation. It's in the form of a squared minus b squared, so the factors are a plus b and a minus b. So this is a difference of squares, so the factored form is going to be x plus 5 and x minus 5. We're going to set each factor equal to 0. X plus 5 equals 0, and x minus 5 is equal to 0. And then by solving both of those, we get x equals negative 5 or x equals positive 5. We can check by plugging back into the original equation. If we check x equals negative 5, plug it back into the original equation, we have negative 5 squared is equal to 25, and that's correct. And we also want to check x equals positive 5. So positive 5 squared also is equal to 25. We have found the solution to that quadratic equation using the zero factor property, but you must make sure that you have a 0 in the equation before you use the zero factor property. Let's solve example M. The quadratic equation 5x squared minus 30x plus 40 is equal to 0. We can use the zero factor property, so we begin by factoring. I notice that all of the coefficients are multiples of 5, so I begin by taking out a GCF of 5, and when you do that, you get x squared minus 6x plus 8. Again, when you're factoring out of 5, it's like you're dividing each one of those terms by 5, and that 5 factor stays out in front. Now we can factor what's left inside the parentheses here. We look at that, since it's a trinomial, we can factor by looking at the last term of positive 8 and finding the factors of positive 8 that will add up to negative 6. And those factors are negative 4 and negative 2. Negative 4 times negative 2 is positive 8, and negative 4 plus negative 2 is equal to negative 6. So in factored form, we have 5 out in front, the greatest common factor. The one binomial factor is x minus 4 and the other binomial factor is x minus 2. So we have this in factored form using the zero factor property. We're going to set each of those factors equal to 0, except 5. 5 cannot equal 0, so that's not going to give us a solution. But we can set x minus 4 equals 0, or x minus 2 is equal to 0. By solving each one of these, we get x equals 4, or x is equal to 2. And as always, we can check our answer by plugging each one of those back into the original equation. That gives us 5 times 4 squared minus 30 times 4 plus 40. Okay, and since 4 squared is 16, and 16 times 5 minus 120 plus 40, that does equal 0. We also want to check x equals 2 by plugging that back into the original equation. That's 5 times 2 squared minus 30 times 2 plus 40. So we get 5 times 4 is 20. 20 minus 60 plus 40, that also does equal 0. So our solution is x equals 4 or x equals 2. In example n, we want to solve the equation x times the factor x minus 4 equals 21. We can't use a zero factor property because we don't have a 0 in the equation. So we're going to have to do some algebra here so that we have a 0 on one side of the equation. Let's begin by distributing the x on the left side, and that will give us x squared minus 4x is equal to 21. Now, in order to have that zero factor property, I have to have a 0 on one side of the equation. So I can do that by subtracting 21 from both sides. And then I end up with x squared minus 4x minus 21 is equal to 0. Now we have a trinomial set equal to 0. We can factor by looking at all the factors of negative 21 and finding the pair that will give you negative 4. And those factors would be negative 7 and a positive 3. So our factored form is x minus 7 and x plus 3 is equal to 0. By setting each one of those factors equal to 0, we get x minus 7 is equal to 0, or x plus 3 is equal to 0. We get x equals 7 as a solution, or x is equal to negative 3. We can check our answer by plugging both of those into the original equation. If we check x equals 7 into the original, it's 7 times the quantity 7 minus 4. So that's 7 times 3 equals 21. That works out. And if we check x equals negative 3, that's negative 3 times the quantity negative 3 minus 4, or negative 3 times negative 7, which is also equal to 21.